this is my term to have a short report about the project we are working on between the Taipei Tech and Professor Daniel Silva in the data science. And last I talk about the story about us. So it's from sponsor from the UAAT, from the University Academic Alliance in the Taiwan, and the Texas A&M University system that's sponsored by the two international partners. And this project is like we back on the maybe more one year ago when I was still in the last few days of the postdoc in the Taiwan Tech. And I received this information from the Yuan Zhang about this project. And we are fighting about the UAAT member from Taiwan Tech, Taipei Tech, with the Professor Lee, also Professor Lee student there. And we started working on this project and this is also the first time we try to reach out to the Danny to work about this project. So today we have totally, until now, we have the 9 months to running this project, and I would like to report to everyone about this project. So yeah, first of all, we have a team between the UAAT member from the Taipei Tech and also Taiwan Tech to building the SAI and do the integration. And also we have some students for working on the communication functions. So yeah, first of all, this project, I would like to thank you some students who are working on this project. From the Taipei Tech, from the Aerospace Institute, Electronic, Computer of the Professor Ling also, and we're building this system. So as I showed some project overview, like what we are working, and also in the next phase, on the conclusion, we want to show about the next phase, we try to reapply for extend this project again on this September, and to extend the more opportunity for Professor Silva, Professor Daniel on today for about the monthly coordinate, but I will show you the later on the next phase of the project. We try to apply on the next month. Okay, so what is the project resource overview? So this process, the overview is we try to yield about the enhance about the Taiwan strength. We try to detect some object like the hidden object, example the shift or the whatever object between the mainland China in the Taiwan, but whatever we can apply more for the other object in the ground. We try to do some AI on board, and then we combine with the communication to working on that. So what we have to do on this project. So the first one we develop about the edge computing on board for satellite for the real-time tracking, and we try to using some SAI for doing the real-time detection and the tracking activity. Second one is we try to keep working on about the communication. So we can find here, we can using the UAV or whatever for the satellite image. We can detect the shift or whatever in the moving object. And then we can using also for the satellite to do the communication, transmit the data, and with the AI result. And we can announcement as soon as possible in the real time. So we have some milestone on these projects. So we have the first one, we have set up the meeting between the NTUT, NTUST, and the TMU for talking about what we do and what each team can have on this project. So we have the system design for the FPGA or the GPU for work on the edge computing, and also for communication for the how we can do the communication, and also for integration. But we are targeted to work on the LEO satellite for the low Earth orbit satellite. But in this first case, we are testing on the UAV payload first, but we will extend to the satellite payload on the next phase of the project. Okay, so you see some project, the team coordinate. We have the Professor Ling and me, and also Professor Lee on the NTUST for working on the Taiwan side. And in the TMUS side, we have the Professor Daniel in here for working. And Professor Daniel is in the morning, right? You see about the multi-urgent, how we can pointing the satellite and the target is the part in the Professor Daniel help us on on this project. And so this project, it begins from the 2024 December until this year, November. So on the next month, we will reapply again for this project to have the second phase of the project. And in this current year, we have working on some important. The first one, we like how we can design the system, how we can design the SAI on the payload, or how we can working on the communications. And right now, like we see, like we have on this phase, right now in the August, and right now we are starting to do the integration and the testing. And we will reapply again on the September for prepare for the reapply for the September. We have reapply again, and we hope can extend from this year December until the next year. And yeah, and we have the discussion with Professor Daniel Eli. We hope on the next year we have some student from the Texas A&M or from the Taipei Test can give the Texas, or from a student from your team can come to our Taipei Test on the next year. So what we do on the first one in the SAI. So actually the first one on the SAI is like we can know like right now the onboard processing, we can using the YOLO or whatever object, we can tracking the shift on by using the satellite image, right? You see the Sentinel-2, it's the ESA satellite image, and we can using it to track about the shift on the satellite payload. But the question actually is the result from my postdoc, the time I also in the Taiwan test. But the problem is like right now, even like in the Lithium-2, the CubeSat project right now also apply this model on the GPU. But the problem is actually it only can run on a few seconds and run out the battery, no power. So the problem of the GPU and is either it has a lot of the power. So pay on this one, when I come to the Taipei test, I will extend for some new model. And I just saw the model, and we try to apply the YOLO pay and improve of the YOLO on the FPGA. And right now we're successfully working on the FPGA with the new version of the object detection. So on this project, one problem we have testing, that's the hidden object. And right now, as you know, like the Ukraine and Russia, they have a lot of using the UAV for tracking the object, right? And the question, the problem you can see, example, we use the YOLO to tracking this first car, right? And we can identify that as a car 1. But if the next frame is framed to the car is hidden by the tree or whatever object, and we move on, go to the next frame, we try to identify, but that's the other car. It's not the same with the old car. So when in following, we will get in, oh, that's a different car. It's not the same car with the frame 1. So we have like adding more model to handle about the re-identify. As we see, we have the extend about the YOLO, and we build about the object tracking, and we handle about the re-identify. Example, we can finding, we have the frame 1 to frame 3, right? The car here, and when the car is like hidden by the brick, and how we can know what's car and how we can follow the car, and we design about the re-identify, like we can predict where the car, when it's in the hidden by the other object, and we can predict, oh yeah, even like the car in this one, but it's like we can predict that's the location with the car, pay on the velocity of the car before it's into the tunnel or before it's into the brick. We can identify by the few frames before we know the velocity of the object, and we will getting by the velocity of the car, we predict where it is during the hidden. And when the car go out, and we can see when the car, we predict based on the velocity of the car when it's go out, we will know, oh yeah, you can see right now, even like in frame N-1, we have the ID3, right? It's hidden by the brick, and after it's go out on the brick, we also can identify on the same car. It means we can tracking, we can following the car, even like where it is or where it's hidden. And also with testing under this condition, we have APC, right? And this case, the car is even like hidden by the tree. But we using the even like satellite image or by using the UAV image, we all can follow the car, and we can predict the exact location where of the car based on the velocity of the object, even like it's hidden by the tree. Okay, and that's the model, the new model we improved from the YOLO, and we have testing on that is for some simulation result when we testing. And I remember it's the video, oh no, later I can show you the video. And that's the new model of the edge computing, and later I can show you the system, like how we can implement the model to the FPGA, and how we can testing with the UAV, or also filter on the satellite later on the integration part. And that's the first model. second model, that's the communication. Actually, this communication is working by the Professor Lin, not by me, but I can shortly to show like how we work. And we have do about the communication part, including we use the order process on this one. We have using the kind of the FPGA board, and we have co-worker between the FPGA and the MCU to design the communication payload for working on this project. And we are testing on the FPGA and the ARM CPU for ZYK and the 7000. And we also design on the RF communication on this one, and we have the testing on the communication part. So yeah, because I'm not an expert on the communication, so I just saw the result, and I just saw what I know about the communication can do. So after we design and we testing on the communication payload, the algorithm and the hardware device, and next step is like how we can do the integration. That's the thing I and some my students is working on, how we can design the new model we have. We design for the re-identify and working on the FPGA. So for the testing, the planning, we have working on the satellite, right? So in the testing for the first year, we have shortly to, because we need to, if we want to do on the CubeSat, we need to redesign the FPGA board. But we don't have the enough time to working with our industry partner, but we are doing now to like scale down about the FPGA to the 1U, and this will be ready to the CubeSat on the next year. But in this first time for the testing, we just using the one payload. Later we will change all the payload to the 1U payload only for the camera, FPGA, and also for the communication. But we integration all the things go to the 1U AV. And we can see that we have the power, we have the payload for AI, we have the one FPGA board in this place, one camera we locate on this location. And also for the communication, we have the one communication payload on this one. We have the one antenna. We can see that's antenna. We have the L-band, and we are successfully testing on the L-band antenna for the communication on this one, and we integration all to the UAV. But it's the first day, and next phase we will move all the payload go to the 2U payload of the CubeSat on the next year. And that's the other project we work on the NFTC, but we will do it, and we have to extend us on the satellite system. Okay, so what is system integration? I think that's I'm familiar for because my background and the AI and the electrical system, right? So we have working with my students to building this system for how we can combine and how we can integrate about the FPGA for the AI and also for the communication together. So that's the process. We have the starting by the image, we have the camera, and after we have the take a photo of the camera, we will using the USB interface connect to the FPGA, and that's a KV. That's the Xilinx FPGA for the KV260 is right now is I think it's we select because it's easy to using the FPGA to writing, and also like each chip is only about 12,000. We have the one kind of the one board of the FPGA, and we bring the model, the YOLO Pay model, and we have improved go to this FPGA board and to process the AI model. After process the AI model, we will transmit go to the communication app, also like the board for the communication. And after for design on the ADRV is kind of the communication payload, we will transmit go to the antenna for the L-band antenna, and then we have transmit by the L-band for the TS and the RS for transmit and the receiver the signal from the L-band. And then we have the decoding using the USRP for the communication and decode the information go to the computer. So you can see like all the process from the starting process on the XAI with the re-identify or the new model of the YOLO for this one, and then put on the RF signal and transmit go to the computer. Okay, and I can show you like some compare. The left one, that's the YOLO model we testing on the YOLO V8 and YOLO V11, but it's the same problem. Like you can see, even like the car, when it's hidden by the brake, you can see ID, and it will finding like the new ID. You can see the car on the new ID, or it's lost the car. But in the new system, the new YOLO model for handle about the re-identify model, you can see even the car right now, and it's hidden, and you can see, even as hidden, we can predict the location based on the velocity of the car on the previous frame, and then we just keep the eye on the tracking object. So that's the new object for the, we have improved the original YOLO model with the new model, and that's the AI model. And about the communication, I can show you some communication. And after we do the integration for the AI model, right, we have working on the communication. And in the Professor Lin, the lab 602, we have the one chamber for testing the communication signal. And after we integrate all the FPGA board for the AI and the communication on the UAV, we print the UAV, go to the chamber for testing of the communication signal, like on this one. And after we testing on the communication signal, we can using the antenna, and our antenna will transmit the data to the receiver and transmit back go to the information for in the chamber testing with the communication part. Yeah, and the distance is from the reflect of the antenna we testing on the 3.4 meter, and that's the size we can transmit on the chamber testing. And how about the communication simulation? So that's the communication done from our student. So we're testing with the size of the image on the normal image for the passage of the YOLO model. We're testing on the YOLO model, and the size of the transmission we can transmit the data under the 68 kilometer. It's not the small distance, right? And we transmit the size of this one, and the data rate will get on 0.8 something, and the decoding rate in the 88.9%. That's already a separate on the communication. Yeah, so that's the result. And the image will transfer. You can see actually that we take photo from our Taipei text, and we take the photo in the expressway, and we transmit this image onto the in the chamber simulator, and we get the maximum rate of the transmission. And and also the student have also testing some UAV fly, and they have the problem. The student talking that you can see the UAV for the flight dynamic is burned out, but we are lucky the FPGA board and the ADRV, the communication board, is not broken, but it's a problem. And right now, my students suggest me to using this one, but we're not testing. We will planning to train about the flight dynamic control for the new solution for handle about the UAV flight. Yeah. And for the challenge on the tracking problem, we can see we have testing of our the UAV for the camera we capture on the Taipei test. We have the view, and we guess it's like have a lot of the challenge on the tracking algorithm. We also need to be working. And and you see my students fly the UAV, and fly the UAV on the stadium of the Taipei test on the high distance, and we try to capture, and we can. So when we try to apply the new model, you can see it's more stable when we tracking the car on this region, and actually it's fly on the building for this building, and we have go the roof of the building and testing on with the camera on the communication system, and we all can get the signal very well during we transmit the image with the AI result, and we transmit by the RF information by using the payload we have on this simulation. Yeah, so that's the system for the integration we would love to do on the next phase. And right now, actually, the system we have on the FPGA, we have the processing, we have on the processing system and the program. We almost say PS and the PL on the hardware, and the PS we have work on the image pre-processing for capturing or shifting, labeling, and also for compression. And the PL is mean like it's pay on the FPGA for handle the neural network. We only work on the neural network pay. So in the neural network we use the PL, but in the PS for the normally work on the MCU system on the FPGA, we will use the image pre-processing, labeling, and compression. And for after we process on the packet of the PS system, we transmit go to the ADRV in the communication, payload communication FPGA board. and then we transmit, go to the ground station. But in the next phase, on the next year, we try to apply that. We can do like, we transmit, go to the satellite, and then forward back, go to the ground station. In case the satellite is like, we fly in a far away from the ground station. So what we would like to do on the next phase, and also like for the flight control board, we try to apply the autonomous UAV system during when they have fly far away from the Taiwan land. We can handle and let the satellite can communication with the UAV can control by autonomous. Okay, so so that's the next phase of this project, and today actually in the morning we will understand more about the Professor Daniel, how he worked on the multi-coordinate and the multi-point target. So in the next phase, we are planning this project will ending on this November, right? So in the next month we try to resubmit again about the next phase for the 2025 and the 2026. And we try to working more about how we can do the multi-coordinate task or multi-coordinate for the satellite, how we can train the satellite and can like follow the UAV, how we can enhance about the communication. So that's the plan for the next year, and we hope can get the funding for the next phase of this project. And also like we will open some student exchange from the Taipei Tech student go to the Texas A&M, or students from the Texas A&M come to Taipei Tech during the internship for 1 to 3 months. And that's our plan for the next year. Yeah. So you see the short report of the project we have working between our Taipei Tech team and Texas A&M. Yeah. Thank you, and thank you for your attention. And that's the project we have working on some professor we working on the two sides of this project coordinate. Thank you. Yeah.